Hello class, I'm working out of your Pre Algebra book 1.8 Scientific Notation. To get started, scientific notation is always begun in the process to get our number between 1 and 10. We'll look at examples of that. Also remember every number has a decimal after it. So 5 decimal, 28 decimal, 1,500,000 decimal. So it's just working with our decimal after whatever number we are looking at in our examples. So if we're asked to write these numbers in scientific notation such as 1,670,000, then you're going to remember there's a decimal after it. Work with that. Our process starts by figuring out where is my number between 1 and 10. That's here, between the 1 and 6. And we work our decimal back to that number. 1, 2, 3, 4, 5, 6. So 1.67 times 10 to the 6th power is our scientific notation for 1,670,000. And when you work that back out, you come back to the original given number that you started with. Another example, if we have 0.00059, you're asked to write this in scientific notation. Our 1 through 10 is between the significant digits 5 and 9. That's where our decimal is going to go. So I have 5.9 times 10 to the something. To get there, you need to go 1, 2, 3, 4 places to the right. And remember, you're already working from a number, an original purpose of your problem. So to get back to this number, if you go 4 places to the right, then to get back to the tiny decimal, you need to make that a -4. So it would be in the reverse to get back to that original number. So we have 5.9 times 10 to the -4 power remains 0.00059. We are asked to write this number in standard form, 6.37 times 10 to the 5th power. Set your number out. And we're going to work 5 to the right. It's a positive exponent. 1, 2, 3, 4, 5. I like to draw an arrow where my new decimal is going to go. And annex zeros in these empty place values. So I'm going to write that 1, 2, 3, comma. For our math notation, 637,000 is equal to 6.37 times 10 to the 5th power, our original problem. We have something like 8.4 times 10 to the -3rd power. Then you're basically dividing by 1,000. You're moving your decimal 3 places to the left. Set your number out. Work that 1, 2, 3. I like an arrow where my new decimal is going to go. Annex zeros in your empty place values. And it's going to be 0.0084 for your standard form number from the original scientific notation. You do need a 0 in front of your decimal, even though in that place value there's no value. When we work with decimals as a student, it's a small math notation, and we just need to be sure that it's caught. So a 0 in front of it helps us catch that it is a decimal we're working with. That's important. Alright, if we're asked to write distances in scientific notation that have rates, for instance, speed of light is 186,000 miles a second. Then we set out our number. We need to work between 1 and 10. That's where our decimal will be placed. Our invisible math decimal is right here, and we're going to see how many back we need to go to get to where our decimal needs to be placed for scientific notation, like a board game. 1, 2, 3, 4, 5 places back. And we're going to say it's 1.86 times 10 to the 5th power and label miles per second. Alright. If you're converting something like 3.6 nanometers, very tiny unit of measure, into meters, a bigger unit of measure. Okay, you have to consider that. What's my small unit of measure? What's my big unit of measure? A nanometer is 1/1000th of a meter. It's taking a meter stick and breaking it into 1 billion parts. They're specks. They're not even specks. They're a piece of measurement that can't be seen with the human eye. Okay, so can you imagine breaking a meter stick up into 1 billion parts? We're considering the math notation in precise numbers through scientific notation in that. Alright, so if a nanometer is equal to 0.000 0.0000001 meter, a billionth of a meter, then we would say that's equal to 10 to the -9 meters. We would have to go to the right 9 times to place our decimal after the 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Okay, so now if that's true, then 3.6 nanometers is now equal to 3.6 times 10 to the -9 meters. So you're just working with a really big place value. You're just working with 1 with 9 zeros after it, a billionth place, and applying the same idea. I hope this helps, and I'll see you soon.